GUC proposal for the IEEE APS Student Design Challenge. Allow us to introduce our team members.
Hi, I'm Mari.
I'm Ahmed.
I'm Maha.
I'm Minna.
And I'm Randa. Imagine that you can charge your battery on the go while going to work or traveling just with a small bag. Let me introduce our system. It consists of rollable textile-based antenna that is made of Archimedean spiral, a box containing the rectifying circuit, the ultra-low power boost regulator, and the supercapacitor for storage, and the support system.
Archimedean spiral was used since it is circularly polarized and frequency independent. In order to keep the system portable, the antenna was built using textile materials for both the substrate and conductive layers. Two different substrates were used: felt to be rolled and fleece to be folded. Also, two different conductors were used, which are shielded super and conductive threads. And to match the antenna's impedance to the rectifying circuit, a balun was used. The impact of the array was investigated, hence the small element was used repeatedly to form the array. A Schottky diode was connected to the center of each element of the array to provide rectification. Finally, DC lines were used to combine the rectified DC voltage or current from each element.
As just mentioned, that one of the most advantages that specialize our antenna that it can be easily fabricated, that you can make it yourself with very simple tools. I'll show you here the fabrication process of one single element using the felt textile as a substrate and the shielded super as a conductive layer that has adhesive backing. You first print your designed antenna on a paper and adhere to the back of the shielded super to ease the cutting process. After cutting the spiral, I'll separate the paper from the conductive layer and iron it to the substrate.
The rectifier circuit consists of 6-stage voltage coupler. Each stage includes two sections, a capacitor and a diode.
During the positive half cycle, the second diode is on and the RF input signal is rectified and the first capacitor is charged. While in the negative half cycle, the first diode is on and the second capacitor is charged from both the input signal and the voltage stored in the first capacitor. So the total voltage is doubled. The antenna is connected to the charge pump through a coaxial cable to the input of the charge pump, and the output of the charge pump is connected to the ultra-low power boost regulator, the ADP 5090.
During testing, two antennas were used, the fleece design as the transmitting antenna and the felt design as the receiving antenna, and was placed 80 centimeters away. In order to record the available RF power and the band of the antenna, a signal generator and spectrum analyzer were employed. From the signal analyzer, it can be seen that at a frequency of 900 MHz, the available RF power is in the range of -95 dBm. Now, you will adjust the frequency of the signal generator to the same value. It can be observed that a peak is detected at this given frequency, where the power increased to -78 dBm. Now, the rectifying circuit is connected to the antenna, and the output is displayed on the oscilloscope. Then, the output of the charge pump is connected to the ultra-low power boost regulator, the ADP 5090, and the output of the regulator is connected across a 100 ohm resistor. The input and output of the regulator will be connected to the oscilloscope, where channel 1, the yellow figure, represents the input, and channel 2, the green figure, represents the voltage across the load.
And now we will test the system outdoors at the GUC campus. We choose a location near to mobile base station.